Have you ever stopped to think about the invisible network of rules that literally keeps our world from, going up in smoke? Today, we are diving deep into the National Electrical Code. It's like the hidden language that turns a bunch of wires in a wall into a safe, functioning home.
Seriously, think about it for a second. There's an incredible amount of electrical power flowing through your walls just inches away from you all the time. What's the invisible force field that keeps all that energy contained and doing its job safely?
Well, the answer, believe it or not, is this: a book. And a really, really big one at that. The National Electrical Code is over 800 pages of super dense, super technical rules. It's basically the Bible for electrical safety in the US, and just its size alone tells you how seriously this stuff is taken.
But hey, don't let that size intimidate you. The best way to think about the NEC is like a giant, super detailed recipe book. Every single rule is a precise step, and when electricians follow that recipe perfectly, the result is a home that's safe from all kinds of electrical disasters.
So for this explainer, we are definitely not going to try to read all 800 pages. That would be insane. Instead, we're going to do what electricians do every single day. We're going to find one very specific rule, and we're going to figure out exactly what it means, and more importantly, why it matters so much.
The source material we're digging into today comes from Chapter 2 of the Code. This is a really foundational part of the NEC, all about the basics of wiring and how to protect those wires. So we're going from this massive library of information all the way down to a single shelf. All right, so to understand the rules, we first have to learn the lingo. Let's break down a few of the key terms so we're all on the same page. Let's start with the absolute most basic building block, a conductor. This is really just the official technical term for a wire. It's the physical road that electricity travels on. Simple, right? But the code needs to be super precise, so it calls it a conductor. Now this is where the whole system starts to come together. A feeder circuit isn't just any old wire. It's a major electrical artery. The best way to think of it is like an electrical highway, carrying a big load of power from your main breaker box to, say, a smaller sub-panel out in your garage. And if that feeder is the highway, then the branch circuit is the local street that takes you right up to your driveway. These are all the smaller wires that branch off from the panel and deliver power to the individual light switches, outlets, and appliances that you actually use every day.
So here's the main takeaway, the thing you gotta remember. The feeder is the big, high-capacity main line, and the branch is the local delivery route. And this difference is absolutely critical in the code because they have totally different rules about how much power they can handle and how they need to be protected. Okay, so we've got our electrical highways and our local streets. But how in the world do we get those wires from the outside of a building to the inside, safely? Well, that's where a very, very specific rule comes into play.
This is it, Rule 225.11. This is the exact recipe from the book that we're decoding today. It deals with those feeder and branch circuit conductors, our highways and streets, as they enter or leave a building. It sounds so simple, but getting this one little thing wrong can have massive consequences.
Now, here's the really interesting part. The rule itself is kind of a signpost. It doesn't actually list the steps. Instead, it points you to other rules. Specifically, it says, go check out this other rule for how wires pass through a wall, and then go check out that rule for how overhead wires get attached. It's a cross-reference, a built-in system to make sure you follow all the right procedures.
Okay, so we've looked at the what. It's a rule that points to other rules. Got it. But the most important question is always why. Why does the code have such a specific instruction for something that seems as simple as a wire going through a wall?
This quote from a fire marshal really just says it all. In electrical work, the smallest details prevent the biggest disasters. A tiny, tiny mistake in how a wire is attached or sealed can, over time, lead to a complete catastrophe. The details are literally everything.
Because if you don't follow Rule 225.11 and the other rules it points to, well, here's what can happen. The wire's protective coating can get worn away, creating a huge fire hazard. The hole isn't sealed right, so water gets in and causes rot and shorts. Wires get exposed, creating a serious risk of electrocution. It's basically a checklist of things you never ever want to happen in your home.
So let's zoom back out for a second and look at the big picture. We went from an 800-page book all the way down to a single sentence that points to 2 other sentences. And buried in those few lines, we found the key to preventing fire, water damage, and serious injury.
And that right there, that's the true genius of the code. It isn't just a bunch of annoying red tape. It's a deeply interconnected system. Its real power is in that web of cross-references we saw, creating this overlapping net of safety that's designed to make sure no single mistake can bring the whole thing down. It really is a blueprint.
So this leaves us with a final thought to chew on. The electrical code is just one example. Our modern world is built on thousands of these hidden rulebooks for plumbing, for construction, even for traffic. What other invisible blueprints are out there, quietly protecting you and your family every single day? Thanks for tuning in.